So in this example, we have radicals on both sides of the equation. Luckily, if you look at it, we see that both are cube roots. They have the same index, so no worries here. Just raise both sides of the equation to the third power. And on the left, that will simply give us 2x plus 4. Now on the right, be careful and realize that we have the 2 that multiplies our expression with the radical, and therefore the exponent needs to be distributed to both of them. That means we end up with 8 times 3 minus x. It can happen that people overlook this and then instead they write 2 times 3 minus x, but that's not the case because the 2 gets the exponent 3 and 2 cubed is 8. So be careful with that. Next, we're going to solve as usual. First, we need to distribute on the right. We get 24 minus 8x. We want to now have all the x's on one side. So we add 8x, add up with 10x, plus 4 is equal to 24. Subtract 4 from both sides. 10x is equal to 20. Dividing by 10, we get x is equal to 2. Does this solution check out? Now we have to plug 2 in for x in two places. So again, be careful with that. We got the cube root of 2 times 2 plus 4 is equal to 2 times the cube root of 3 minus 2. The cube root of 2 times 2 is 4 plus 4 is 8 is equal to 2 times the cube root of 1. We have already figured out that the cube root of 8 is 2. Cube root of 1 is of course 1. 2 times 1 is 2. And yes, the solution does check out. Okay, so in this example, we have a square root that we need to work with. And on the left, we have a binomial. So let's see what that actually does for us. First, we're going to raise both sides to the second power. Now on the right, we now have 7x plus 15. Have successfully gotten rid of the radical. On the left, we had a binomial that we multiply by itself. X plus 1 times x plus 1. We need to FOIL this, and we get x squared plus 2x plus 1. A quadratic equation. Now, how are we going to solve this? We need to move everything to one side, so we have the equation being equal to 0. In other words, we're going to subtract 15 x squared plus 2x minus 14 is equal to 7x. And now we subtract 7x from both sides. And we get x squared minus 5x minus 14 is equal to 0. Now that looks like the type of quadratic equation that we have dealt with a lot in the previous unit. And that's why that is so helpful, because quadratic equations pop up in all sorts of places. We need to solve this quadratic equation. Let's see if we can factor it. Target sum is negative 5. Target product is negative 14. Which factors of negative 14 work out to give us a sum of 5? And the answer is negative 7 and 2. So we got x minus 7 times x plus 2 is equal to 0. For our two solutions, x is equal to 7 and x is equal to negative 2. Now we have two solutions for the first time, but still we need to plug them back into the original equation to see if they check out. So starting with 7, we do 7 plus 1 is equal to the square root of 7 times 7 plus 15. 7 plus 1 is 8, which is equal to the square root of 49 plus 15. It is equal to the square root of 64. And that is indeed the case. So this solution checks out. And on to the next one. Negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. Negative 1 is equal to negative 14 plus 15. Negative 1 is equal to the square root of 1. And the square root of 1 is 1. So negative 1 is not equal to 1. So this solution doesn't work out. Negative 2 is an extraneous solution. Bad negative 2. So that one does not work. In our learning objective, we said that we can solve radical equations both algebraically as well as graphically. Now, graphically, we can do it two different ways. We can do it on the calculator, or we can do it using a transformational approach. This equation that we have here, we will first solve algebraically and then graphically and compare our solutions. Here we have two terms with a radical, and in order to be able to solve them, we're going to move the square root of x to the other side to get square root of x minus 3 is equal to 3 minus the square root of x. And now we can raise both sides to the power of 2. Get x minus 3 is equal to, and now on the right we yet again have something of a binomial. That means we need to FOIL. 3 minus the square root of x times 3 minus the square root of x. 3 times 3 is 9. 3 times the negative square root of x is negative 3 times the square root of x. Negative square root of x times 3 is another negative 3 times the square root of x. And the negative square root of x times the negative square root of x is positive x. Now let's clean this up a little bit. We get 9 minus 6 times the square root of x plus x. And now we can move both our 9 and our x to the other side to isolate the term with the radical and do this work one more time. X minus 12 is equal to the negative 6 times the square root of x plus x. Subtracting x from both sides, we get negative 12 is equal to negative 6 times the square root of x. Now let's divide by negative 6. 2 is equal to the square root of x. And now we're going to raise this to the power of 2 one more time, which means 4 is equal to x. So that is the solution we get algebraically. Now let's go ahead and graph these two equations. In order to do that, I'm going to rewrite it slightly. The square root of x minus 3 is equal to the negative square root of x plus 3. And the reason why I did this is so it looks more like we can use the transformational approach that we have practiced. I'm going to use two colors too. So we have f of x, which is equal to the square root of x minus 3 that we want to graph. And we have g of x, which is equal to the negative square root of x plus 3. Our first function, we start 3 steps to the right because of the negative 3 underneath the radical. We don't have to go up at all, and the dilation is 1. So here's our first point, and our second point is going to be 1 to the right, 1 up. next point 4 to the right, 2 up, and those are all the points we have. And here is our function f of x graphically. Now let's graph g of x. G of x starts 3 steps up. It doesn't have to go to the right or left. And here is our first point. But we have a dilation of -1. That means we have to flip the graph. So when we go to the right, instead of going 1 up, we go 1 down. And as we go 4 to the right, we go 2 down. And here is our other graph. And those two graphs cross each other at one point. And that point is indeed the point where x is equal to 4. So x is equal to 4 is the point where both equations and both functions are the same, indicated by the fact that they are crossing each other. Very good, and that's the same solution we got algebraically. So we have solved this equation algebraically and graphically. Well done, you guys. And that's it for today. I will see you in class.